Zero, industrial IoT, and especially we focus on such topics as data science, predictive analytics, etc. So the main idea, again, I pointed out every time, is for us to share knowledge on how far are we in implementing predictive analytics in industry. So we focus very less on actual algorithms or whatever innovations there are, but we focus more on actual use cases to see if it's actually being implemented anywhere and how is it being implemented. And of course, we want to share the knowledge so that we kind of build a network. And one of the things that I had in mind was also sharing the knowledge between the areas or the countries. So we've had so far talks that were mainly from Germany. And I think that other countries have uh, definitely other experiences and have other targets and goals. And that's why our speaker today, Sandro, he will talk about Switzerland and the Swiss data center, and also give information about many use cases as far as I know. And I think you can introduce yourself way better than me. So, what from my side I want to add, in case, do not hesitate to turn your cameras on. And um, Sandro will be our first and the only speaker today, so we will focus only on this topic. So no hurries, no big agenda. And about the actually how it's gonna go, Sandro, it's all up to you. So whenever you're ready, you can start.
Yes, thank you for the introduction, Azada. Thank you also to you and Selma for the invitation. Very happy to be here. Hello, everyone. Um, Indeed, as mentioned by Azada, I think we have enough time, so feel free to interrupt me, ask questions. I hope you can all activate at least the microphone and ask directly questions. That would be very nice if we make it a little bit interactive. Let me try to share my screen. And maybe I will just need one okay for someone, as I don't see the room anymore now. Is it okay, Azada?
Yes, it looks good. It looks perfect. And also, one last thing, just to remind you, we will be recording this session in order to have in future some recording of it. Yes, it looks good, Sandra.
Perfect. Thank you very much. So yes, very happy to be here. I have two main objectives today for this presentation. Is first to introduce you to the Swiss Data Science Center, why there is such a center in Switzerland, how we work, and especially how we work with companies. And then I have a second part of the talk, which is maybe the biggest one, which is to share with you some different projects I worked on before joining the Swiss Data Science Center in different industries, and I think this project could be interesting. So not all of them are strictly speaking into Industry 4.0, but I think they are still interesting and happy to share that with you today. So just a few words about me. I have experience in academia and in different industries in Switzerland. I'm now leading the industry side of the Swiss Data Science Center. I also teach in a class between EPFL in Lausanne and University of Lausanne. And I also founded the Swiss Association for Analytics to promote data science and analytics in Switzerland. And I have basically worked in different companies, always about trying to leverage data, making sure these companies can really benefit from the data. And I think this is quite interesting in our domain to be able to really each time learn a new domain, meet some new people. And I think it's for me every time really discovering new use cases, very interesting to discover these things one after the other. And so let me introduce you to the center and tell you a little bit more about what we have here in Switzerland. But I will start with this cartoon. I will let you go through the cartoon. I think it's quite interesting. It may look like a bit funny, but unfortunately, we see this situation quite a lot. So this is not only a cartoon. This is also real life, and we see a lot of companies that indeed have a lot of expectation about digital transformation, about trying some to deploy machine learning and AI in their premises, and trying to think this is done, in a few months with an intern or a master student, and then this is done. So our message is basically that we can help into this. This is a long journey, and there is no reason why different stakeholders, whether the academia or industry, should do it alone. So the center in itself is a joint venture between the two federal schools in Switzerland, ETH in Zurich and EPFL in Lausanne. And the main idea is to make sure we help accelerate the adoption of data science in Switzerland. And that means a lot of things, but mainly we are divided into three units. So we have a software development unit, and we develop a platform called RENKU. I will tell you just a little bit about this. We have another unit about academic projects. So how do we help labs in this institution to make sure they can do machine learning projects? And the third one, which I will focus more, is about the industry side. How do we support companies in Switzerland being more data driven? Here I just like to show this picture because this is one particularity of the center, is that we are quite big compared to other center in academia, is because we not only do the link between academia and industry, but we also do the project ourselves, meaning when there is a need for a project with an academic institution or with a company, then we hire data scientists, and these are full-time employees of the center. And I think this is a nice way because these different people, they can interact. They have their main project, but they can definitely interact into other projects, bring their expertise, and we can really leverage a lot of people like this in our different collaborations. So on a few words on the academic side. So we mainly work with the ETH in Zurich and EPFL, but also 4 other institutes that are part of the ETH domain in Switzerland. And the most important things for you here to know is that we tackle different problems in different areas, right? Environment, political science, personalized medicines, and so on. And that is quite nice because, again, the people working on this project, they are at the PhD or postdoc level, and they have a lot of experience in machine learning, and they can definitely be leveraged when we do industry projects with our partners. We have more than 40 projects ongoing, and usually the duration for this project is about 2 years. Another thing we also do at the Swiss Data Science Center is to ensure that whatever is done in data science or science more generally is reproducible and reusable. And this is why we developed the RENKU platform, which is an open source platform to try to do the same thing like you will do with Git on code and versioning things, but really at the level of the code, the data, and the result and everything environment. So the main idea is to be able to reproduce what was done at any point in time, understand who did what with what data, what was the result, and make sure that you can always redo these kind of things later on. And I think this is both useful for academia to be able to reproduce things that is done from one lab to another, and to industry also, of course, when you have data scientists leaving and you want to be able to reuse what was done before. Now, if we turn into industry, if you think about typical way to put a bit of the different level of the data maturity in companies, so you can go from the bottom part where there is no analytics at all in the company to the analytical competitors, and this is one way of dividing it, which has been proposed by Tom Davenport in his book Competing on Analytics. And the main idea here is just to say that the companies can be a different level, and where we play our main role is really, I would say, the non-data driven company, or the one that are really aspiring to be more data driven. We do have a few exceptions where we tackle also analytical companies, but let's say we believe that that where we need to help Switzerland is really more into these traditional companies, whether they are into banking, manufacturing, pharma, and so on, but they are not data driven by definition, and they need help to go in that direction. And now to conclude this introduction about the center, let me just tell you a little bit the different ways we have to achieve our objectives. So here I show a little bit 3 axes that we have today to support the different companies. what I call deliver, educate, and transfer. So if we start with deliver, we have on the top the proof of concept. So this is basically making sure that these companies, they can already start data science projects. So that's where our data scientists solve some use cases from companies. And we also have obviously our academic experts. So this means that when they work with us, they have mainly one data scientist working for them. But of course, there are then all the other people that can help if we need to have specific expertise in machine learning. The second axis is educate, and that's, of course, we are school, so it's really one of our main mission to be seen as an education platform. So we provide feedback, and we do it in an objective way, in a sense that we don't have anything to sell, we don't have tool or solution to sell to our partners, and we also do a lot of training and events. I think this is really important for us. We believe that, I mean, for these companies to become more data driven, not only to need to have the resources, the people to do it, the use cases to be solved, but also the different stakeholders in the company to be trained so that they understand a little bit about data science, AI, and get a bit of demystification about these topics. And on the left, you have the transfer part, which is really about how do we help these companies build their own pool of data scientists. And that means not only trying to help them when they hire data scientists, which, for example, they can do through us, meaning we hire the person is at the Swiss Data Science Center, and after a few years can transfer to the company. So we really started having now people transferring from our offices to our industry partner, which for us is a key success. And also the campus immersion, which is more about saying, okay, you have data scientists, maybe they are lost somewhere in your company. What about they come on the campus, they network with our people, they learn, they get coached, they participate to a reading group and so on. And this is quite appreciated from companies because this is a good way for them to retain their data scientists. This is something in addition they can offer to them that you don't find in, let's say, traditional training catalog within a company. So this is just to show basically that we have different means to approach companies, to interact with them. And of course, this has been developed in a few years, but I think this is quite interesting and quite comprehensive now, and quite unique as well. I think there is no other institution, at least we are aware of in Switzerland or even in Europe, that is, providing from these use cases, training, and also transferring people to the companies. So that's it for this introduction about the Swiss Data Science Center, and I suggest that if you have further questions, then we can of course discuss at the end of the presentation. So now I'm going to share with you a few example of predictive analytics project. These are examples I worked on before joining the Swiss Data Science Center, that they have nothing to do with the center, but I think it's still interesting. It's completely different industries, different companies, and different use case, as you will see. And I think the idea is really to think a bit about what could be done with data science and predictive analytics in the industry in general. And of course, as was mentioned by Azada, I will not focus on the technical part, which is, I don't think, the interesting part, but more on let's say, the context, the challenges that we faced, what was the lesson learned we had on these different use cases. So let's start with the first one. First one was done at Nespresso. So it's about forecasting coffee sales. So we are talking here about capsules that Nespresso is selling. So Nespresso is basically producing all the capsules in Switzerland and then selling these into different countries around the world. And one of the key things that Nespresso needs to know is a little bit what is the people are going to consume in the following months. And this is important because basically you want to avoid being out of stock in some countries or in some boutiques, and you want also to avoid having overstock and having issue on your working capital. So all this process of trying to build this forecast is part of the demand planning team, which is itself part of the supply chain. And this is a lot of discussion between supply chain, salespeople, finance people to agree about these numbers, what are the forecasts for the next months, and to agree that this is the real quantity that the people are going to order, because this is important then to know how many capsules you're going to send to different countries in the world. And so in that case, we used some forecasting models to try to predict the sales of these capsules. So the main idea is basically to work on a monthly basis here. So you have a history of sales, and you try to predict for the next month what is going to be the consumption of coffee capsules. And this is done per month, per market, but also per SKU. So, for example, you try to have for each month in the upcoming months to whatever forecast horizon you have, you try to predict this for each countries, and then in each countries for each product. So you try to predict for all of the coffee you're selling in France, in Italy, in Spain, and so on and so on. And this we do with different things. So of course we use the sales history, meaning what you have sold in the last few months, but also some additional data sources. And here, I don't know if it's, I think you should be able to unmute yourself. And I'm curious to know basically if you have any ideas or suggestions, what kind of data we could use to help improve the forecast in addition to the history of the coffee sales. Does anyone of you has a guess, an idea? I hope you can unmute yourself. Is it the case?
Um, Sandro, can you read the chat?
Oh
I
yeah,
think
sorry. So let me.
there are some answers, but guys, you can also always can
Let
ask.
me check. Yes, weather is a good point. To be honest, with the weather, we don't really need it explicitly because we use monthly data, and as we work on a monthly basis, we don't use weather for a specific location because we predict anything that is sold in France, not or specific location, for example, in France. So this is not something we use explicitly. But of course, if it's warmer in summer and you sell less coffee, then of course this is implicitly taken into account in the sales that you use. Machine capacity, yes, it's a good point, and I think this is something we would have used a bit more before when the patents were still protecting the machines. But as the market has opened and basically you have compatible capsules, this is less of an impact. So we tried some analysis there, and we saw basically that indeed selling now an espresso machine doesn't mean you will sell the capsule afterwards. So I would say the impact now is reduced. But indeed, that's a good thing. Yes, the holiday as well. So this is a key factor. So for example, in Switzerland, we have a day of holiday, the 1st of August. And we saw, for example, that the impact from one month to another of this August, from one year to another, if it's on a Sunday or on a Monday, it can change up to 4% of the sales. And this is quite interesting because if indeed you don't tell to the algorithm, this is open days, there is no way the algorithm can find by itself that, this 1st of August is closed or open, or is it on Monday or on Sunday. So yeah, we didn't went as far as looking for tourist capacity and these kind of things. Marketing campaign, yes, so that's a good point. We used data from marketing campaigns. So very high level data, meaning if you do a big promotion in France and you say, well, I'm going to do, you buy this and you get that for free or whatever, and it has a strong impact on the sales, then we do indeed ask the market to send this information so that we can include that in the forecast. So in the factory, it's not something we use. So it's more, I would say, a supply problem in our sense. So for us, we try really to forecast the demand, which for us, the demand is just the sales, because we take the assumption that we are always selling to the maximum capacity that the customers are asking. And yes, all of this we also thought about. We didn't went that far as looking at social media data. We looked, for example, at competition, but there again, we had some data, very high level, from some provider, but it didn't improve really the forecast. One thing we do use are the CRM data, because of course at Nespresso you have information about customers. Again, here we are talking about some key indicators at very high level. For example, number of new customers in Italy per month, or average consumption in Spain, and so on and so on. So this is something that we indeed include. So let me maybe continue here. And I think you had very good. Oops, let me try from there. You had some very good idea. So in the end, in this project, what we want to do is provide sales forecasts to the different markets, so to the different countries that Nespresso is operating. And we want this to be data driven, and we want basically to replace what people are doing manually in different countries to something central. And in the end, what we have is we want to operate from the HQ of Nespresso in Switzerland, use any sales data, CRM data, plus some others that you mentioned, put that into a forecasting system that is operated by the data scientist. Then we generate the forecasts in an Excel sheet that we share with the market. On the market side, they have a demand planner, which is basically having the final word on this forecast, deciding what really the country wants. So basically, the forecast is an input. You can fine tune the forecasts, send that back to the HQ, and then the supply planner will provide the goods to the different countries. And here you may ask yourself, why Excel? I mean, there are some technical reason for tools not to be aligned from the HQ to the market. But also one good thing about Excel is that the tool can sometimes be a showstopper for such a project. So if people say, no, I don't know how to use that tool, the good thing with Excel is that no demand planner around the world could say, I don't know how to use Excel. For this, we use different time series model, ARIMA, exponential smoothing, and so on. So overall, quite simple models. But again, here you don't need very complex things. It's working quite well with simple techniques. A few lessons learned on this project. So what we discovered that whatever people told you, they want to know how you obtain your forecast. And we had this question in the beginning of the project. We said, well, to our stakeholders in the end, if you need to have a better accuracy in your forecast, or if you need to understand your forecast, what do you prefer? And everybody will tell you, I want higher accuracy. This is a lot of quantity, a lot of money in play, and so we want best accuracy. And of course, when you do your forecast, in the end, nobody cares if you're 95 or 94% accurate. But then they ask you, why is it so high for France? How come is it so low for Italy this month? And so on and so on. So we took the input, but in fact, people said something and they wanted something else. So we had then to react and make sure to be ready to explain your forecast. Here I'm talking about time series forecast, but that's the same for classical prediction problem. And the main point is that you need to be able to justify when you are sharing a number where people may expect something else. Why is it like this? And this is not always easy, but we learned a lot about that. And every time we're sharing forecast to make sure that we have some explanation related to this forecast. Another thing as well is to manage expectation, and that takes a lot of time because in the very beginning of the project, you have more of the people who are skeptical about this. So they say you will never be able to do it. A human is always doing better and so on. And when it works, then basically you have the other way around. So people have over expectation. So they ask a lot of things. And here, my point is that if you have a main initiative like this that you want to organize from the HQ, share to different markets, then you need to be realistic. So when people were asking every day, can we have a what if analysis about that? Can you do it, per zone in the country? Can you do it per warehouse and so on? So we had to be realistic and to say no, because if we have been in all of this direction, then we will never have been able to scale this project, which is now running and sharing forecast with 40 countries around the world on a monthly basis for more than 2,000 SKU. And I think this is a price to pay somehow. So if you want to have something that is scalable and in production, you may have to say no to a lot of small requests from your stakeholders. And in this one as well, and it's true in most projects, I would say that, of course, building the trust takes a lot of time, but it's very easy to break it. And an example is, for example, when we shared the forecast, you can do whatever backtesting you want, but you put the system in production. After 1 month, they look at the forecast. 2 months, they only look. 3 months, they only look. And only after 3 months, they started saying, well, it looks really great. Let's start using it. And so this takes months really for people to believe that this is working. And you can show whatever test results you want before. So they want to see it live somehow. But then again, if you share some stupid forecasts for any months, for any market, then it's very easy to lose the trust because people say, oh, but in fact, it's a black box. I don't understand. And now your forecast is completely wrong. And I don't believe it anymore. So there we had to make sure we keep the human in the loop, which for us means there are data scientists working on this, but also a team of 4 or 5 demand planner in the HQ, just making sure everything is running properly, that whatever forecast we generate, we have a look at them before sharing with the market and make sure this is something realistic that makes sense. One easy example is your model may be the best one from whatever metrics you measure. If it's a flat line for the next 18 months, nobody will believe that, right? Nobody will use it. And so if people don't trust your forecast and they don't use it, then you don't have impact. So this was really key to make sure that not only the forecasts are good in terms of precision and accuracy, but also that they make sense when you look at the forecast, you look at the numbers. Good. That's all for this one. As it's I want to avoid stopping each time the presenter, so I don't see the chat. I don't know, Azada, if there are some questions. Otherwise, I can go to the next one, and then I mean people can ask questions in the end for the three different use cases, if that's fine. Or
It's up
do you
to
want to
you.
pause here? We can pause here. I just need to stop the main screen. So
I can also read the questions if you like. You don't
no,
have to.
I've just stopped the plain screen, and that's fine. So I can see the question. Yes. So
We
yeah,
have a couple of questions. I'm sorry,
yeah.
Sandra. Just in case anybody is having a problem turning on the microphone, we can do it. Otherwise, feel free also to write the question. Sandra can read it. Okay.
Yeah. So yes, outliers. I mean, this is something that we had to do when doing the forecast indeed. So this is where again the scalability plays a role. So maybe you can do it when we do the forecast overall for the market. Of course, you will look if you have some points that are strange, and that you can specify in the tool that. Of course, we try to understand what is the reason for that. Maybe there were something specific that never happened, and then you correct that and you make understand to the system that this is an outlier and should not be reproduced, for example, next year and things like that. So that we are able to handle. But then, of course, at the SKU level, you automate a lot of things, so the outliers are a bit more tricky. So it's usually more feedback from the user saying that there is something wrong. For convincing the stakeholders, so the main thing that we did basically, so in the beginning, of course, there were a bit the discussion between, you have the demand planner doing it manually and you have the tools that is doing it with, I mean, for people of obviously some magic. So first we were showing that the results were good. So, I mean, if you show the accuracy and you calculate the accuracy per month, you will see that it's at the same level or better than what the human was doing. But we went also further because that would just mean, maybe you should replace the person. But we showed basically that when we share the forecast and the demand planner is using that and fine-tuning for some things that he or she knows specifically for his or her market, then the forecast will be even better. And that was a really good way for us to show that it was working well. So not only show the accuracy, but show that look, these markets they are using it, this one they are not using it, and look at the difference. And of course, then we could measure a lot of things like what is the impact on the finished goods stock, what is the impact on the promotion that you do last minute because your demand plan is bad, and so on. So you could measure a lot of things to show the value. So no, we didn't use neural network in that case. So we used simple time series model, which again were working really well. So we didn't have to go further than that for the data that we had in this case. Yes, I think things like lockdown are very tricky. So a situation like COVID will indeed be you will need to do something very particular and to see I mean how to adjust the forecast or how to make sure you're not just blindly following them. And I think it will be a little bit the same like we had some region in the world where they had a price change. So usually Nespresso is not changing the price of the coffee, but you may have, for example, in China at one point in time a price change. And if you don't know about it, and if it's the first time happening, there is nothing you can do about that. You have to see what happens and then input the information into the system. So I think the same way here, when you have this kind of situation, you will need to discuss with the business, see how to handle that, and make sure this is not obviously reproduced the year after into the forecast. Good. Should I move to the next one? Okay. Perfect. Let's go to the second one. So the second one is about completely different topic and industry. We're in the online travel agency here with Expedia, and the context here is basically for a company like Expedia. which is commission driven. So basically, if you're a hotel, you want to get visibility, you go on Expedia website, and if you're Expedia, then you charge this hotel a certain commission, a fee every time someone is booking a room through the website, and this is the way they get the money. And for Expedia, what is interesting is when you have a set of hotels, you can try to measure what is the revenue that they generate for you. Meaning, if these hotels are on the website, every time someone is booking them, you will get a little bit of money. And if you sum up this money over a year, for example, then you will see what is called the revenue of the hotel over a year. And the main question for Expedia is which hotels you should onboard. Here I write acquire, but when we say acquire hotels at Expedia, it means acquire that on the website. Which one you should acquire to generate revenue. And so if you have a new one here, this Résidence du Roi Hotel, then the question is, what will be the value it will generate to Expedia if we were to onboard that hotel? So after a year, how much money you will make with that hotel. So here you can obtain data to try to do this prediction in different ways. It's mainly by using data that you scrape from different online sources. And the main objective here is to really predict the value of the hotel for Expedia before the onboarding of the hotel on the platform. And here maybe also I can just pause a little bit because I'm curious to know what do you think are kind of data that Expedia can use to predict the revenue that the hotel will generate for them. So information about hotels or things related to hotels that people that Expedia can use. Yes, booking indeed. So we have to think here. I mean, it could be internal data, but that should also be available for the hotels Expedia are not working with. So location, yes, latitude and longitude. Very interesting here, location, because you cannot throw latitude and longitude in a machine learning algorithm, but we were drawing square around a specific for each specific hotels and doing the average of other hotels in the same region that Expedia was already working with to have a first estimate of the hotel value. Yes, TripAdvisor is a very good source of information. So we were scraping a lot of information there, reviews about people on these hotels, number of rooms, yes, and this is one of the key factors. And the number of rooms is really a key factor, a key impact factor, telling you the value of a hotel. Yes, clustering of similar hotels. So this is done in different ways if we want. So using geographically the latitude and longitude, but also, of course, using information like star rating and things like that. So whatever you find interesting about these hotels. So I think we covered most of it. So yes, we didn't went as far as looking at the pictures and things like that, but that could have been the next step. So something about computer vision and also text mining with the text of the reviews. So how is it working? So you have a set of internal data. So let's say the hotels that Expedia is already working with at that time was 300,000 hotels. And then, of course, you have all the information there for the hotels, number of rooms, star rating, location, and so on. And then you try to get the same data, which you scrape from external websites, competitors like booking.com or TripAdvisor and so on. And this, then you can have here a central system, which we call the lead prediction system, which basically you have a data scientist operating that, meaning we built a machine learning model here using stochastic gradient trees. And the idea here is to have then a forecast that we apply for using this model to all the hotels that are out there. So in that case, where we had about 300,000 hotels, we were estimating the number of hotels still potentially coming on the website to be 1.5 million. And then you can discuss this estimate, but that's basically when you look at sources like TripAdvisor and so on. And these numbers then, they are shared with the salespeople. So this means that at Expedia, you say, okay, for each hotel out there, I will provide this metric. So I will tell you what is the forecasted value of that hotel. And then the salespeople, whether they are in London, in New York, in Paris, they can rank the hotels according to this metric. And they can say, well, okay, this week I can only approach 10 hotels. Then I will go with these 10 ones. And the idea is that they go obviously with the one that bring most value once they are on board of Expedia. A few lessons learned here as well. So here we found out that when you do such kind of project and you share a number with the salespeople, we were very happy first when you improve your algorithm, you add some data, or you improve the machine learning algorithm, but then it generates variability. And this is a real issue for the trust of stakeholders. So meaning if you update every week or every month and the numbers are going up and down for a given hotel, then the people say, well, it's a joke. Are you kidding me? I take time to approach hotel. I set up visits, we discuss, I explain them Expedia and so on. And then you tell me now it's not worth anymore having this hotel on the website. So we had to be very careful and put some limits in what was the variability allowed from one update to the other, to make sure it is not impacting the trust of our salespeople within Expedia. Data quality is a challenge for all data science projects. In that case, what data quality meant was basically when we had issues sharing a forecast and the salesperson was coming back to us and say, look, for that hotel, you're completely wrong. We were first starting to investigate if there is a problem with the model, with the code and so on. And of course, what happened 99% of the case, it's just that you have issue with the input data. So we would say, no, this is really the forecast we have for this hotel. It's 200 rooms. And then the person will say, no, this is 20 room. And then you come up to the source and you see that you have an issue. And even sometimes the data we were scraping from TripAdvisor, for example, was wrong. So we found cases where the number of room was not correct. So again, I would say here the best advice is to any issue you have, first look at the input data before changing anything. And in that case, or of course, if you want to build a model with a lot of decision trees, you want to fine tune it, you want to do it on huge data sets. This can take a lot of time to train, and this is also to take into account some approach you can easily parallelize, some not. So be ready just to take into account that if you want to update your model every now and then, is it the correct? Do you have the time indeed to try a few things? Update the models, do some tests, and if every time you need 2 days to build your model, then it might be an issue at some point. So just taking this into account is quite useful. And maybe it's time to pause here if you have any questions on this project at Expedia. So in that case, we didn't use specific NLP techniques for the prediction of the hotels because we didn't use the text from the reviews. We only used the numbers that people were putting on TripAdvisor. But the NLP side we still use in the deduplication. So when you scrape data from different sources, you have 10 times the same hotel, but they have just slightly different names or address and so on. And it is very time consuming for people to manually try to merge this hotel. And so we developed an algorithm that was on top of this one I just presented you. Well, the goal was just to say, okay, from all the hotel we grab, then we want to make sure that when there are 10 hotels, there are really 10 different hotels. And we were using, in that case, text mining and fuzzy matching to try to merge different hotels together. Do you have any other questions on this use case? If not, then I will move to the third one. So the third one is about detecting counterfeit products. And this is a project which was done at SIGPA. So SIGPA is a Swiss company providing track and trace solution for governments to detect fraud, but also mainly ink for banknotes. This is the most known one. So all the banknotes you have in your wallet, they do have some SIGPA ink. At the time, SIGPA was working with about 80% of the governments around the world to sell the ink for the banknotes. And here, this is another division of SIGPA, but it's a bit the same idea. So you want to protect some products. In that case, you want to protect products that government puts tax on, and you want to avoid counterfeit. You want people to do the fraud. So basically, you put stamps or you put ink, visible or invisible ink, directly on the product. And what happens is that you have auditors, custom officer, and so on that can use handheld device to authentify this product and make sure that there is no counterfeit in specific manufacturing sites. How this works is basically once you have the ink on the stamp or the product, then with the handheld device you emit a signal, and then you in response get a specific specific light that you can then analyze within the handheld device. And this was the input we were using to basically try to detect whether what was analyzed at the moment was genuine ink provided by SIGPA, or if this is something else that we should not count as genuine ink. So the approach in that case is basically, you can see on the left here, you have example of such signals. So you get some spectrum over the frequency. And so you can just imagine this will be a vector, right? So each time you measure some ink or not, you get such a signal. And so this will be a row in your data set with the value of each of the points in the column. And so you can collect as much data as you want, because you can produce the ink yourself, and then you can scan anything else that is not the ink. And so this is how we built basically two data sets, one by saying, okay, this is the genuine ink and this is anything else. And the goal of the machine learning algorithm there was to build these rules that we would then implement on the device to be able to detect the ink. So you go on a new sample, and the device will tell you if this is genuine or not. In that case, we use a mix of decision tree and correlation to do that. We didn't use something more complex because we had some specificities with the handheld device. So this is not, you cannot do deep learning and apply that to such device, which has very limited memory and capacity on it. So you have to be very careful also about how the solution is going deployed, and what are the limitations related to this. The few lessons we learned on this project. So as I said, the deployment on the solution is really a source of constraint. So it's really key to start with the end in mind and ask yourself, who is going to use what I do now? How is it going to be deployed? On which system? What is the update frequency? And so on and so on. So all these questions, maybe you cannot answer them from day one, but it was very good we asked ourselves this question not too far in the project, because we went with some more advanced techniques, and then we were thinking, okay, let's do this support vector machine and things like that, and you go to the software engineers working with the device and the programming language of the device, and they were just laughing at you and say, well, you can never do that. You have a few kilobytes of memory, of disk space, and so on. So we end up understood that, okay, we have to do something that you can translate into if-then rules, and that they will be implemented into the specific programming language of the handheld device. And if you know that quite in advance, it saves you a lot of time. Here it was also interesting because in that specific project, which is not always the case, but we could collect data, right? We could collect samples from both the two classes of the problem. And we understood that data variability is really key in such project, because the more, it's not about just collecting more and more sample, but making sure you do a lot of things to change the environment. And one thing that we found was, for example, we did a first model, put that in production, went into some devices, and then it was working in a lot of cases, but not in one cases. And we understood, for example, that the auditor was left-handed, and we did all of the recording with right-handed people. And that can just change a little bit how the tool is used, the lighting, and so on. So we really, and then you can correct that, because then you can have left-handed people collecting data and updating the model and so on. But it is really key to make sure that if you have some action that you can do on the data collection process, to just design it carefully and make sure that you try to do as many things as you can to increase the variability of your data, and this will make your solution more robust. And we end up finding, I guess, what I've been experiencing in a lot of projects is that in that case and in the others, I mean, usually more data beats better algorithm. And that means you can always try to fine tune the different techniques, try another one, fine tune the hyperparameters and so on. And you will gain a few percent, but adding more data, improving the quality of the data, more diversity in the data, variability, and these kind of things is really where you get this huge increase in accuracy. So I would say if you have to focus on one aspect after having the first version of your product, is really more on the data rather than the algorithm side. This is it for my third use case. I don't know. I'm really close to the end. I don't know if you have any question here on that one. Yeah, that's a good point. I mean, the imbalance class, I mean, we made sure that basically we were collecting the same number of genuine cases and non-genuine cases to build the model. But obviously, then in practice, you will have much less cases of fraud. So we had to make sure also we were agreeing on what is the respective false positive and false negative that the business will accept, and what is the price, let's say, if you're not detecting something that is a fraud, and the other way around. And so, yes, the perturbation on the movement, slightly different angle. So that we were basically, and that is where we try to increase the variability. But to be honest, that was really manual. So it was just people collecting data and collecting data. The thing is that there is obviously one part that you can, try to improve the model. Then the real sigma ink is giving you, if you remind this graph I show, it will give you one of the curve, right? So if in the end people are able to reproduce the exact same ink, you can do whatever you want to, to do some perturbation. If they produce the same ink, then of course the tool will detect it. So we had to go as far as making sure that whatever will differ slightly from this ink will not be detected as ink, and I think that was working correctly. So yes, we were making sure. I mean, we standard approaches like cross validation and so on to that there is no overfitting on the model, and in that case, what we did was a bit of feature engineering for the variable. So we used, for example, if you have a vector of 150 points, which are these points on the graph, then we were also adding some information, because this just tells you the level. So maybe you want to have the slope between the points, so you can also do some additional calculation, like doing the difference or the ratio between the one point and the other, and get additional data and see what that gives. Yeah, in that case, I mean, educating the clients about the topic. I mean, this is of course you have different clients. So I would say there are the clients that needs to understand, like the people doing the software development on the device, that needs to implement the solution and so on. And to be honest, I remember at the beginning it was very hard, because people say, but I look at the curve and I put myself somewhere you need to check. And we explain to them that, okay, but in that case, you will still do a lot of error, because a human cannot look at thousands of curves and find the best point, but a machine can. And so we had to explain this to the engineers. Now, I would say for the final user, meaning the inspectors, the custom officer, and so on, they don't really need to know how it works, right? They just have the device, and it's detecting the thing for them. And of course, I guess it's also not in the interest that people know too much in detail what's happening. Yes, I mean, if there were some additional restriction, indeed, using dimensional reduction would have made sense. We didn't have to do that in that project. It was still feasible this way. Again, we didn't have thousands of variable, but maybe 200 or 300 in the end, and so that was still manageable in that case. Good. So maybe I will just finish. I'm really close to the end. Um, Yeah, I just had one last slide, and I think this is an important point in this project as well, and an experience we have at the Swiss Data Science Center, that we feel there is still a bit of a gap in between what data scientists think they will do, and usually it looks a bit like that, right? They think they will do a lot of fancy stuff, they will do deep learning and all of this, and what happened in industry, it's a bit more like this, right? So there is a lot about data preparation, and then the rest is about complaining about it, and that's a joke, of course, but I think it's still important that we make sure people understand what you have to do in this project, and that nowadays, with all the tools that we have at our disposal, the algorithm that are available, and this, it's not a lot about machine learning, right? It's much more about data science. So it's about all the process from understanding the business problem, meeting the people, getting the data, iterating until you get something working. But again, once you have a machine learning model which is working good, you should not spend the next 6 months trying to fine tune that, but rather go into the next use case and try to solve the next use case for the company. I usually like to share book recommendation in all my presentations. So if you like to know a bit more about the limitation of AI, especially deep learning limitation, I advise you Rebooting AI from Gary Marcus. Very interesting books. Also in terms of limitation and a lot of application like self-driving cars and so on. It's very interesting. The one in the middle by Melanie Mitchell. And if you want to read a bit more about the issues of machine learning and black box model on society and in general and privacy and ethics, I would advise this weapon of mass destruction by Cathy O'Neill. And I'm done with my presentation. So again, I will come back to the screen here to see if there is any questions. At least I had a lot of questions during the presentation, so that was very nice for me. So thank you for all your questions.
That's what
It was
I was
good.
gonna say. If you have any more questions, sure.
I see. Yes, I see one. So, so maybe you want to. Do you want to? Okay, okay, I see. So, what do you mean exactly, Daniel, by takes? What do you mean, like how is it adopted by the business, or the time to create it? Okay. Um, so yes, it's quite different. I would say the last one was maybe around 6 months. Of course, then I'm not counting the development. So the device was developed physically and the software and so on. But I would say all the interaction we had with the people and having some solution, then it never ends after 6 months. So then you have, of course, further improvement to do and meetings and so on. The one at Expedia is this kind of never-ending project. So it was there when I started. It's still there after I left. So I think you can always improve the solution, include new data sources, and so on. But there were a lot of questions about, yes, there's this frequency of update. How do you do that? And then we spent a lot of time sharing and explaining to the business. And it's the same for Nespresso. It took 2 years to from the very beginning to try for the first year with a few pilot markets, and then the second year roll out to 40 markets. And most of the time, again, here is not really on the technical side, but of course you need to develop the solution and make sure it's sustainable. But really sharing with the people, we spend countless hours presenting, by time zone in the world to the different demand planners, to the different people in marketing, in sales, in finance, how this works, why we do it like this, what you can gain from it. And, even to the people, I think this is also a responsibility of people in data science. When you do something that automates part of the job of someone, like a demand planner in Spain, then you need to make sure they understand what they could do else with that time, right? Because if they feel replaced again, they are not going to use the solution. So we spend a lot of time into this explanation, into this training session, and all of this. Yes. So here we basically have what I would say the people which are best able to care about the ML ops side or the monitoring of the system on the Nespresso side were basically the demand planner. So here again, it was interesting because people were demand planner, but then they shifted to what we call the demand analyst job, meaning you're a demand planner and you have some knowledge of statistics and a little bit of knowledge of data science so that you can use this system. And these were the people that were making sure that it's still working well, and they will analyze all these numbers and all the forecast on a monthly basis to make sure that we are not sharing just numbers that don't make sense with the business. And this is really key also to explain to the management, because people think, if you do a forecast for one country, then you can easily do it for 50 country. And of course, we try to explain basically to the management, tomorrow we can generate forecasts for 1 million SKU if you like, but this will all be automated. And if people don't understand the numbers and they don't trust the number, then they don't use it. So we had to make sure that people understand we need to invest time into monitoring these numbers and analyzing them before sharing. And I think that's one of the key points. People sometimes try to make the comparison between data science and business intelligence. Whereas in business intelligence, you're more into a deterministic world. So once it's done, if it's working, it's working. Whereas in data science, you never know about the forecast, right? So you may end up with something completely crazy and that don't make sense. So you have to be careful about these kind of things.
Um, if while we're waiting for any more questions, maybe I can ask one.
Yes, sure.
I don't know if the question sounds a little strange. It's not really about the use cases you mentioned. I was wondering if generally, like all these technologies that we are talking about today, and is there and there is a huge demand on the market. I mean, we all know that most of the industries and companies are trying to implement those for many reasons. I was wondering if there is any work being done on implementing analytics towards sustainability. I mean, you mentioned this environment about predicting avalanche, etc. I mean, is there any way that new technologies, let's say data science, machine learning, AI, can help industries towards being more sustainable?
Yes, I think there are some initiatives. I mean, I don't know about the details, but I know there are a lot of initiatives about sustainability, about the circular economy, and things like that. And I think indeed people are questioning. I mean, what is the role of AI and machine learning in this project? So yes, I guess this will come more and more.
Mm-hmm.
And or I mean, movements like AI for goods and things like that. I think it's really important. But I don't have any specific example
Sure,
to
sure, but
share.
there is a demand, or it could be even
Yes.
more. Okay. Yeah, we have more questions.
Yes. So if the stakeholders acknowledge the limitation of ML models, I would say it depends. Yes, I think there is this kind of over expectation. So again, it can go from which we have seen in an espresso project. So people don't trust you in the beginning, or even they were surprised. You share a forecast and they say, but how can you share a forecast for our market? You don't even know when we do all of this promotion. And indeed, in the beginning, we didn't input promotion information, but still, it works somehow. I mean, not perfectly, but it works, and people are surprised. And you have to explain, well, I mean, this is working because it seems this promotion don't have that much of an impact. Look at the data, and this is. I mean, you have to be politically correct. I mean, you cannot come to people and say, your big promotion, it's just shifting the demand, which may be the case in reality. So you have to find the right way to, I mean, to bring that on the table. Um, but I would say usually it's not really the case. They don't see the limitation, and this is one big risk, is that you do such a project for 2 years and then people ask, and this happened, people ask and they say, well, now I want the same thing on all the data, a little bit different and so on, and they expect you to do this in 2 weeks. And of course this is not happening like this, because there are a lot of things you develop specifically, sorry, for this project. And so also I think there is the time notion. So they don't see the limitation of machine learning models saying, you do a forecast in time, but of course, the further you go in horizon, then the less good will be the forecast. And I think that's you can expect that, um, and that there is no there is no magic. So that was really the idea, to explain how the forecast was working, to make sure they understand this. And something unrealistic they will ask will be, okay, we have a price change, in this country. It's the very first time. What is going to be the impact? And we say, well, if it's the very first time and it's hard to compare from one country to another, then we cannot do a lot of things with approaches that are based on the history, because if you don't have example of this in the past, then what can we do? So this is things that we had to deal with.
So, are there any more questions? I guess not, and I hope everyone hear me? I had some trouble at the beginning with my internet, but Sandra is smiling, so I guess everyone can hear me. Yeah, I just want to say something. I want to thank you, Sandra, for finding the time tonight to talk here in our meetup group. Thanks to all of the attendees for joining us this evening and not being shy to ask any questions, because like Azada said, this is what it is about. We want to not just present all the hot topics, but hear what you also have to say and hear all your feedback. So if you guys have any feedback for us, how the meetup went, if you have any questions, if you want to do a talk yourself, just get in touch with me or Azad and we'll get back to you. Hope you guys have a great evening and we'll see you next time, hopefully.
Thank you, Selma and Azada, for the invitation. Thank you all for your question. It was really great. Have a good evening.
Thank you.
Thank you. Bye, guys.
Bye.
Bye-bye.
See ya.